Thanks for the introduction. Thanks for using up some time to give people the chance to come in. Still some seats free here. All right, let's start. Let's see if I can make it in 42 minutes. All right, what am I talking about? I'm talking about platform engineering with Spring Boot. Why? Well, I'm a platform engineer, you could say, probably. I'm an engineer at Atlassian. Who's using Atlassian products? All right, that's probably 80% of the room. Just to set expectations. If you have issues with Jira or Confluence, of course you can come to me, and I'll debug your issues. But let's do that after the talk, okay? So 50 minutes, and then you'll come. Yeah, so I work on the Java platform team or Java tech stack team. There's not a single name for this team at Atlassian. And obviously, Spring Boot is one of the central pieces of that tech stack. Otherwise, I wouldn't be standing here. About 800 services run in production on Spring Boot, on the Java tech stack. Ask me how I know that number. I know that number because we migrated 800 services last year from Spring Boot 2 to Spring Boot 3. That's the only reason I know. You would think it's easy to calculate to count the number of services running on a particular tech stack, but it's an NP-hard problem. Anyway, platform engineering, what is that? As every good developer does, I looked it up on Google and found this definition on platformengineering.org. Platform engineering is the discipline of designing and building tool chains and workflows that enable self-service capabilities for software engineering organizations. So let's check if that applies to me. So I work for a software engineering organization. I work for the core engineering organization at Atlassian, and we provide the platform for other teams to build their services upon. So Jira and Confluence runs on that platform, at least the cloud versions of them. We build tools, mainly libraries. I'm going to talk a bit more about that. I'm going to talk a lot more about that in this talk. That the other teams, that the developer teams at Atlassian, building these 800 services, can use so they don't have to reinvent the wheel. And all that is self-service, so the teams can choose to use it, or they can choose not to use it, although we obviously recommend to use the tools that we provide, because it saves them time. And the ultimate goal of platform engineering is, of course, developer happiness. We want developers to be happy with the platform. If you ask corporate people, they would say the ultimate goal is developer productivity, but it's the same thing. Happy developers are productive, and productive developers are happy. So what does that have to do with Spring Boot? At Atlassian, and probably in many other companies, we build microservices. So if you look at Jira or Confluence, it's made up of like hundreds of little services that do single things, and they run on a platform. And that platform, at least for the context of this talk, is made up of things, of platform features. And platform features are, for example, logging, where does the application have to send the logs so we can look at them in Splunk. Tracing, how can we trace requests through this maze of microservices that we have. Authentication, authorization, metrics, alerting. Deployment, how do I deploy my service? We don't want every team to manually deploy their services with a command line or from their laptop. We are even not allowed to deploy services from a laptop for compliance reasons. And all this stuff. There's a bunch of stuff that every team, a bunch of features that every team, every service needs, and not every team needs to build this for themselves. So we build a platform for them. And the microservice, the services the teams build are on top of that platform. right on the very top. And between the platform and the services, there are some integrations. So we need to teach the Spring Boot applications, the Spring Boot services, we need to teach them to use the platform features. We need to configure them in a certain way to integrate them with the platform. Yeah, and on the bottom of it all, there's a cloud provider. In our case, it's AWS, but there are others around. And in our case, these integrations are built with Spring Boot. Like I said, Spring Boot is a very central piece of our Java tech stack. And Spring Boot is a platform by itself. It provides a great platform to build services upon. It makes it easy to integrate. And we build on top of that, build some integrations for our teams to use. So that's what we're going to talk about today. Before we dive into the code, so I'm going to show basically, for most of the talk hopefully, I'm going to show some code. Let's talk about the tech stack, the Java tech stack at Atlassian, because I'm going to take some examples, example integrations out of that to show you in a minute in the code. So what does the Java tech stack look like at Atlassian? So we have libraries. That's what I said earlier. Some libraries that have nothing to do with Spring Boot, and some libraries that are Spring Boot starters, Spring Boot libraries that integrate certain platform features for the microservice teams. So that's the main focus today. We also provide guides for the developer teams, how to do things. We provide standards for them, recommendations. Hey, if you need this feature, if you need this capability, then please use this framework and not that framework. And one of the main recommendations is use Spring Boot and not some other application framework. Because the more people, the more teams use the same kind of tools, the less sprawl is there in the company, and the easier it is to switch between teams, for example, and to take advantage of the platform. And lastly, we also provide project setup, something like start.spring.io, which I assume you know, so people can create new projects, new services from scratch, but do it in the right way with our recommendations. And this is what it looks like in our platform at Atlassian. The cloud provider at the bottom is AWS for us. Then we have these bunch of platform features that build on top of that. And then we have our Spring Boot integration layer. And on top of that is the microservice. And we provide a parent POM for those services. So you probably know Maven. And the services using Maven, they can just import that parent POM. They can extend from that. And they get all the dependency management and everything set up for them. We also provide a BOM, a bill of materials, pretty much like the Spring Boot BOM you might know, which includes Spring Boot, but also other things. So they use the right version of different libraries. And then we have a bunch of Spring Boot starters, Spring Boot libraries that integrate with certain features like security, the web frameworks, MVC and WebFlux, to add some opinions to those that we use at Atlassian. I'm going to show some rather simpler integrations today. Hopefully, you can take some of that home and get some inspiration. All right, so I'm going to show some code. All the code I'm showing is on this GitHub repository. And I'm going to do something revolutionary. I'm going to take questions during the talk and not at the end of the talk. So after each code example, I'm going to look around and try to find someone who's raising their hand, and then you can ask a question. Why am I doing that? Because you know Parkinson's law. Who knows Parkinson's law? What does it say? Yeah, the job takes the time you allocate for it, which means that a talk always takes all of the time and there's no time for questions at the end. So I'm going to take questions in between, because I know there won't be time. So I'm going to ask in between for questions. Anyway, let's look at some code. Let's look at the first example. So I'm not going to start with 1, I'm going to start with 3, obviously. So one use case which is not quite platform yet, but which is a very simple thing. Spring Boot sets a lot of properties for us, a lot of default properties. They're mostly sane properties, good defaults, but some of them we want to change. So our teams should have a different value of certain properties. And we don't want every team, like we don't want to tell the teams, hey, please set this property to this value. We want to do it for them. So as an example, there is the property, the tracing, the sampling probability for tracing, which means, in this case, the default value, I'm not sure if this is the real default value, but in this case, it's 0.01, which means that 1% of all requests will send a trace to whatever tracing server is configured. But we want teams, at least in their local environment, we want this value to be at 100%. We want every trace to be recorded in local development, because you don't want to try 100 times and then get some traces locally. So how do we do that? There is this feature that we call, that Spring Boot provides, called this annotation property source. Very simple, so you can see this is an auto configuration that I created, tracing auto configuration, marked with the auto configuration annotation, which tells Spring Boot to automatically load it. This only works because it's mentioned in this file called auto configuration imports, and you can see it's the first line here. And Spring Boot looks into that file, looks into this list of classes, and knows, okay, I have to run this configuration when the application starts. So that's how the configuration is activated, and then you can see in the first line, the property source annotation says, hey, please load this properties file and add it to the environment. And that properties file contains the default. So this is the default that we want to set in production. Services should have 10%, this is made up now, I don't know what we set as the real value, but services should send 10%, in 10% of the request, services should send traces. That's the production default we want to have. Services can override it. They can still change the value in their own application properties. I think. I'm not sure what takes precedence, actually, if this takes precedence or the application properties. Anyway, this is the value we want them to have in production. But then we also have these here. And this says we want to load a file called tracing, and I called this env name. Imagine this is an environment variable that gives the we're going to talk more about environments in a minute, but the environment name could be local, for example, or it could be prod, or it could be staging. So it also loads this properties file, and this properties file, do I even have it here? Yeah, tracing. So if this environment variable is set to local, tracing dash local.properties, then the value is being set to 1.0, 100%. And that's just a very small thing, but a very convenient thing to do. And people could still override this by adding their own tracing.properties file into their service. That would take precedence. All right, any questions so far? I promised questions. Yes? Okay, question is, what can you put in the parent POM that you can't put in the BOM. Doesn't have anything to do with what we just talked about, but anyway, I'll answer the question. So parent POM, so a BOM is for basically dependency management, right? You have, in Maven, you have this dependency management section where you can say, okay, from this library, I want this version, and this library should have this version. And in the parent POM, you can configure more. You can configure the build itself, the Maven build. So the BOM is just managing dependencies. And if you inherit from a parent POM, you can set certain Maven properties. You can add Maven plugins and configure them. That's the difference. All right, let's move on. Next thing, let's do this maybe. So, environment variable translation. So, if you run services on a platform, it's probably in a Docker container, and the platform injects certain things into the application, into the Docker container as environment variables. So all the configuration your application takes should come eventually through either the application YAML or properties files, which are baked into your application, or if they need to be external, like secrets, for example, you don't want to hard code secrets into properties or YAML file, then you inject them via environment variables. So the platform injects certain configurations via environment variables. And the platform evolves over time. So one environment variable may become obsolete, but we don't want all 800 services to have to react to that. So for example, in this example here, there is an old environment variable, and the platform team chose to change the name of that environment variable from old endvar to new endvar. The value stays the same because the value is still needed, but they changed the name because the new name is better. The new name better explains what the environment variable does. So don't call your environment variables new endvar or old endvar. And we want our services to be able to work with the old or with the new environment variable. So they don't need to do anything when the platform team decides to deprecate this old environment variable. So how do we do this? Let's see. And this is where the first time we actually implement a certain extension hook in Spring Boot, namely an environment post-processor. The environment post-processor expects us to implement the post-process environment method, and that basically gives us the option to modify the environment. And the environment is basically just a bunch of key value pairs from different sources. So key value pairs from your application properties file, application YAML files, key values from system properties, key values from environment variables, all bunched together in the environment. And what we do here is just say, we read the old endvar and the new endvar endvars. I should have chosen better names. From the environment. And then if the new environment variable is not null, I'll translate it to the new property that the people can use, that the teams can use. And they can use that with the old version of the platform or with the new version of the platform. It doesn't matter which of the environment variables is injected. And otherwise, if the old endvar is set, we're going to set this property. And then we're going to add the map that we created here as a property source to our environment. And that works because we tell Spring Boot in the spring.factories file that it should process this file, this environment post-processor for us. So again, Spring Boot, when the application starts up, looks into this file, sees this translate environment variables class in there, and then calls this method at the right time. It's done before all the auto configurations because the environment has to be ready for other auto configurations to be active. So we make use of that for different reasons, many different things. Translating an old to new environment, to new properties, basically abstracting from the platform. So the services don't even need to know the names of the environment variables. We translate it for them into proper properties. Any questions around this? I don't see a hand. Okay. Cool. Then let's move on to the next. All right, next use case. We are going to set some profiles. So this use case is very, very central to our platform, to our micro Spring Boot libraries. The platform injects an environment name. So the platform knows which environment the application is running in. So we just give it a Docker image. The platform takes the Docker image and then creates a container for that image in staging or in production or in the dev environment. And then it injects the name of the environment and the type of the environment for that matter. So the name of the environment would be something like US East 1 or dev US East 1 and staging US East 1 or something like that. And the type of the environment would be dev, staging, or prod. And we want to activate certain Spring Boot profiles based on that. So the platform injects the name of the environment, and we want to activate a profile in Spring Boot. For those who don't know what a profile is, I'm going to show in a minute. Okay, profiles. So, and that looks something like this. This is a bit more code. So again, this is an environment post-processor, same method as before. It also implements ordered in this case, which asks us to implement this method. And we just tell it, please run this environment post-processor before this config data environment post-processor, which is one very central environment post-processor in Spring Boot itself. Our post-processor has to run before this one because we are activating profiles, and all other environment post-processors should react to those profiles or should have the opportunity to react to those profiles. So this is running before. And then in our environment post-processor, we extract the environment name from the environment. Again, the platform has provided the environment for us via environment variables. We extract the type. So you can see here, extracting the name, we're just getting this environment variable in the example. The type, like I said, the type is something like prod or staging or dev. And we have another thing called worker groups. So our services can run in two modes. One mode is as a web server, and one mode is as a worker. So not every service needs a worker node, but for example, if a service is consuming messages from a queue, we would probably want to do that in a worker node, and that worker node should not react to web requests. So they can the web requests and the working nodes, the web nodes and the working nodes can scale apart from each other, so they don't independently from each other. So we extract these, the environment name, environment type, worker group. We log some info. This is very important because teams will ask questions otherwise. If you don't log this information on startup, they will not know what's going on. And then if for each of those things, if the environment variable is there, if the environment type is there, we are going to add a profile to the environment with the same name. And we do the same for the environment name, for the environment type, and the worker group. So in the end, we might have 3 profiles active. We might have a profile that says we are running on, let's say, dev US East 1. That's a dev environment, and not a staging or a production environment. And that would be the environment type dev. And we are using the web worker group because it's a web server. So those are the profiles that might be active for a node, a service node in the end. And then we can, I have a test here. Our teams can use it like this. So this test, for example, sets the environment name to dev east. And then we can check via environment get active profiles if the profile is actually active. And I've set some properties here. Where are they? So some profile-specific property. So this is the default value in the application YAML. And then in the application -dev.yaml, it's set to dev. In the application dev-east.yaml, it's set to dev east. And this way, the teams can use different application YAML files for different profiles. They can use the Spring Boot profiles as they were meant to be used. And they can just use these pre-configured profiles that we give to them. So we activate the profiles for them. They don't have to worry about it. They just need to worry about reacting to those profiles. So if they want to set a certain config property to a different value in production than in dev, for example, they can do that exactly like this. Any questions about profiles? Yes?
If you run this one before the environment post-processor, you cannot override the environment properties here, right? You cannot translate, use the previous.
Sorry, again, I cannot override properties?
Yeah. In that case here, you cannot do the translation of that environment, for example, because you are doing this one before the translation, right?
Well, I could do it. So the question is, could I do the translation of environment that I showed earlier in this one? I think I could, because, well, I mean, I could do all in one, but I would have to do it after, no, you're right, I would have to do it after adding the profiles. So I would have to do it, I could do it in the same thing, but I would have to do it here, I guess, after the profiles are set. I know, it's working like this. So do the profiles first, then do everything else, because otherwise the other environment profiles can't react to the profiles. Any other questions? Yes? Can you speak a bit louder, please? Yes, so the platform injects the environment variable depending on where it runs, and then our environment processor takes that environment variable and activates the profile. Okay. Who's responsible for injecting the environment variable in the first place? That's your question, right? That's the magic of the platform. So I can tell you how I think it works. Like it's some levels below me in the platform, but so like I said, when we build a service, we publish a Docker image to a repository somewhere, to a Docker repository, and then if we merge a pull request to master or to the main branch, for example, in a service, we have an automatic pipeline, and the pipeline triggers a deployment to, say, staging. So the pipeline gives a signal to our central service that manages all the things. I've never seen this service, but there is one. And tell the service, hey, please publish this Docker image to this environment. And then it takes the Docker image and does whatever magic it does, some CloudFormation magic with AWS, sets up a load balancer, blah, blah, blah. And then injects the right environment variables because it knows, we told it to deploy to staging, so it injects, so it puts it in the right network, in the staging network, and then it injects the right environment variables. Does that answer your question? Okay, cool. All right, one more. Yes?
How do you handle it and variables in the local development? That could be a bunch of variables.
Yeah. Good question. How do we handle environment variables in the local environment? The answer is we have a tool that, a dedicated tool that basically that uses Docker Compose to spin up all the resources your service needs. So if you say your service needs a database and it needs a queue and whatever not, it spins those up for you in Docker, and then it injects the right environment variables into your service. Yes, we've built that ourselves, yeah. But it's basically Docker Compose on steroids. You can think of this. It's a bit more than Docker Compose because it takes care of actually starting our own Docker image as well, our service, the service I'm building, plus the Docker containers for all the surrounding things our service needs. And by starting our service, it injects the right environment variables.
If you don't mind, we can talk about it.
Yeah, we can talk about it later, like after the talk. Yeah, you got it. All right, let's move to the next. Which one? I should have done these in sequence. All right, yeah, good. I have 10 more minutes, okay. This might help a bit to understand what we just talked about, local testing especially. So this use case is our platform works like this. We have what we call a service descriptor. It's a YAML file. You can see it on the left here. And the service descriptor contains some metadata for the service. And the service descriptor, among other things, contains a list of the resources that the service needs. So it needs a Postgres database, or in this case, what I showed here, it needs an SQS queue, or it needs an S3 bucket. So basically just a bunch of metadata for the service. And by the way, this service descriptor is used by the local testing tool. So it knows, oh, it needs an SQS queue and a S3 bucket. So I spin those up, and I inject you with the right environment variables for those. And yes, the platform injects, for each of those resources, injects certain environment variables. So the names are examples down here. So for the SQS queue is called myQueue, and then it injects the environment variable SQS underscore myQueue underscore name URL, whatever other properties are there for the SQS queue, so that the service can then use these environment variables to connect to that queue. Same for the database, same for an S3 bucket, everything is similar. And the platform also takes care of spinning those resources up. So when you deploy the service for the first time, it also creates the SQS queue and S3 bucket for you. And now we want to make these environment variables for the SQS queue or the S3 bucket conveniently available, accessible to our service teams. And we want to do that by providing them with a dedicated bean. Like in this case, a bean of type SQS queue properties, for example, or S3 bucket properties. And then they can just use this bean and create their own client. Or we could even go a step further, and we've done that actually. We don't just create these properties for them, we create a client for them already that's pre-configured, connected to that S3 bucket or SQS queue. So how do we do that? That is a bit more involved. Let's see how far we get. It starts with this auto configuration. The auto configuration, again, is registered with Spring Boot, and this auto configuration creates a bean of this type, which I called SQS queue properties registrar. So it registers SQS property beans. That's the meaning of the name. This time, it's not an environment post-processor, but it's a bean definition registry post-processor. That's not a simple word. But this allows us to, well, obviously, post-process the bean definition registry. And the bean definition registry is, yeah, well, it's what it says. It's a registry of bean definitions. And a bean definition, well, yeah, it's a definition of a bean before it becomes a bean. So that's how Spring works, right? You have a bunch of bean definitions. You collect them in a registry, or Spring collects them in a registry. And then at some point, it has all of them together. All beans have been defined. And then it transforms those bean definitions into actual beans. It instantiates the beans and puts them in the application context. That's how, at least, I make sense of it. I sweat the details here, but that's roughly how it works. So what we can do here in a bean definition registry post-processor is we can add new bean definitions to this registry. And that means we can basically dynamically add beans to the Spring application context. So we could also, of course, define them in a configuration with the add bean annotation, but that's a more static thing. In our case, we want to be a bit more dynamic because we want to read the environment properties, SQS queue name, SQS queue URL, and stuff like that. And then for each of and then we group them by the name of the queue. So we could have more than one queue, for example. So we have to group them somehow by the name of the queue. And then for each name, for each queue, in the end, we create a new bean definition, and we add this bean definition to the registry. And the bean definition says, basically, it's a bean of this class, SQS queue properties, which is just a record containing all the config data we need for one queue. That was the wrong button. And then we say, we set the instance supplier, which basically said, if you want to create an instance for this bean, please use this instance, which we just created here already. So that's what it does. I'm going to skip the detail code. It's on GitHub if you want to look. And I'm going to head to the test. Where's the test? And then if we test this, we can do, by the way, why is it doing this? This is a very helpful tool for testing auto configurations and configurations in general. The application context runner, so you can create an application context runner, you can tell it, please use these auto configurations, in this case only the one I just showed. And then in the test, we can run this application context runner with certain properties. In this case, I, for example, injected environment variables for 2 different queues. And then I can assert, I get the application context, and then I get all beans of the SQS queues property type. And then I can do assertions on those, and I can assert that I have 2 objects of SQS, 2 beans of type SQS queue property with the right values. So that's a very, it's still relatively, I mean, it's a bit more involved, but it's the most complicated part is probably parsing these environment variables and organizing them. We have to extract them by name and group them and then create the properties beans and stuff. But it's very, very helpful, very convenient for the service owners to just use these properties then. One interesting thing, because we now have multiple beans of the same type in the application context, how do we use these beans? because when you inject a bean that's of type that's multiple times in the application context, Spring will complain and say, hey, I expected that there's exactly one bean, but there's actually two. So what you can do, for example, is you can add your own annotation, your own qualifier annotation. I called this queue properties, added the qualifier meta annotation to it. And if you have looked closely here, in the registrar, I'm using the add qualifier method here. And I'm adding a auto-wire candidate qualifier with this annotation. And I'm pass in the name of the queue. And that means the end user can use it like, where is it? Can use it like this. So they can use, well, I'm using auto-wired here because it's a test. In production code, you don't need auto-wired, but you can just inject an SQS queue properties object, add this annotation, add this qualifier annotation, and then you know you get the properties for this queue or for this queue, for example. Okay, I'm going to skip questions for this part. You can come after the talk, so I can get through the rest. Yeah, maybe just very quickly, another thing that we do for the platform is best practices. We want to, this is the wrong image. I'm just going to show it in the code. Who knows Flyway? Okay, for those who don't, Flyway is a database migration tool, so it tells you to migrate from one state to the database to the next by adding certain fields or so. And by default, if you use Flyway in Spring Boot, Flyway has an integration with Spring Boot. It runs these migrations, these database migrations. So if you look here, a database migration might look like this. It's just a simple create table in this case. And the second one is an insert into that table. And by default, Spring Boot runs all these migrations at startup time, which is potentially dangerous because if you have a big database and you say, change the name of a column or do some modification on the database on a very big table, it might take minutes or even longer. And during that time, the load balancer might ask the service node, hey, are you healthy yet? Are you healthy yet? And the application will say, no, I'm not healthy yet because I'm still running database migrations. And then eventually the load balancer will say, okay, I'm giving up on you. I'm just going to shut you down. I'll pull up a new node. But the new node will also run this migration. And then it will start over. And basically, you have the chance to break your deployments with a bad database migration. So what we want teams to do is we want them not to run database migrations at startup, but we want them to run after the application has started already. And then they click a button, run the migrations, and then they can debug, or they can take however long they want, but they don't interfere with deployment anymore. So what we do is we have this Flyway auto configuration, and we tell we have a properties configuration properties here with a value migrate on startup, which we set to false by default. And then we use this value. We define a bean of type Flyway migration strategy, in which you can use to change the Flyway migration strategy, obviously. And we ask for this property, which is by default false, and only then do we migrate. Otherwise, we don't. So by default, we turn it off for all teams. And then we provide a endpoint. This is an actuator endpoint for our services. And then the service teams can use this actuator endpoint to run the migrations. So that's just one way of setting best practices to teams and kind of forcing teams to use best practices. Okay, I'm going to go back to the slides, skip those because I showed. I'm skipping this because it's too complicated. Probably also skipping this. Just one thing. You can enable the features, the auto configurations you build. You can consume them in different ways. You can use an import annotation. You can use your own annotation, enable my cool feature, which basically is the same thing. It's just the import annotation hidden behind a different annotation. But please don't do this. Don't use enable type annotations and then put them on the application class. This way you break the modularity of your application, because every time the application runs, even if it's in a test, it will always enable your feature. It will always run your auto configuration, even if you don't want it to. And that causes issues. We just had a case like this a week ago where someone did a slice test, data JPA test or something, or WebMVC test, and had an annotation on their main application class, and the test honored that application, honored that annotation, tried to find some beans, but the beans weren't there. So that's a problem. So the best way of actually activating your features, your integrations, is by using a config property and then use a conditional on property annotation to activate it only on this property. I'm going to skip those, but you can ask me questions about this. So I was going to talk a bit about how to encourage teams to actually use the features that we provide. If you're interested in this, come to me after the talk. I promise I'll stay. And that's it. So if you are interested in more about Spring Boot or anything, have a look at these books. The rightmost one is only in German, sadly. I'm working on an English translation. It's coming out in July. The other ones are available in English. Yeah, and feel free to come to me to talk about platform engineering and Spring Boot in general. I'm happy to talk and exchange ideas. That's it. Thank you very much.